Planet Mars. Mars, often called the Red Planet, has fascinated humankind for centuries. From ancient civilizations gazing at its reddish glow in the night sky to modern space agencies sending robotic explorers to its dusty plains, Mars has always occupied a special place in our imagination. The fourth planet from the Sun, Mars stands as both a symbol of mystery and a potential future home for humanity. Its striking appearance, defined by its rusty iron oxide surface, makes it one of the most recognizable celestial bodies visible to the naked eye. When we think of Mars, we envision a cold, desert-like world where the winds carve dunes across vast plains, volcanoes rise higher than any on Earth, and canyons stretch deeper than the Grand Canyon. But beyond its physical features, Mars represents a question that has echoed across generations. Is there, or has there ever been, life on Mars? The allure of Mars lies not only in its beauty, but also in its similarities and differences with Earth. While it is smaller, colder, and drier, Mars shares characteristics that make it a candidate for exploration and colonization. Scientists have discovered evidence of ancient riverbeds, dried-up lakes, and minerals that can only form in the presence of water. These findings suggest that billions of years ago, Mars may have been a much warmer and wetter planet, possibly capable of supporting microbial life. This tantalizing possibility fuels missions from agencies like NASA, ESA, ISRO, and now even private companies like SpaceX, all aiming to unlock Mars's secrets. Culturally, Mars has played a powerful role in human imagination. From mythology, where it was often associated with gods of war due to its blood-red appearance, to literature and film, where it has served as the backdrop for epic tales of invasion, survival, and discovery. Mars is not just a planet. It is a symbol. It embodies human curiosity, resilience, and the drive to reach beyond our world. The thought of stepping foot on Mars evokes awe, the reddish soil crunching beneath boots, the thin atmosphere requiring protective suits, and the sight of Earth shining as a distant star in the Martian sky. In scientific terms, Mars offers a natural laboratory for studying geology, climate, and planetary evolution. With its thin carbon dioxide-rich atmosphere, seasonal cycles, dust storms, and polar ice caps, it provides insight into processes that could help us understand not only Mars itself, but also Earth's history and future. Exploring Mars is like looking into a mirror of what our planet might have been, or what it could become. The planet also presents challenges that push the boundaries of human ingenuity. Radiation exposure, low gravity, extreme cold, and lack of breathable air are obstacles that must be overcome if humans are to live there. These challenges make Mars not just a goal, but also a test of humanity's ability to adapt and innovate. The story of Mars is not just about science. It is about dreams, fears, and the eternal quest to find our place in the universe. Each rover that touches its soil, each orbiter that maps its surface, and each mission that imagines the journey of human settlers brings us closer to answering profound questions. Are we alone? Can we live on another world? What will it mean to be a multiplanetary species? Mars holds within it not only the history of a planet, but also the potential future of humankind. Mars is a world of extremes, smaller than Earth, yet home to some of the largest geological features in the entire solar system. To understand why Mars captures so much scientific and human curiosity, one must first look at its physical characteristics. These traits shape not only the planet itself, but also the possibilities and challenges for future exploration and colonization. Mars is the fourth planet from the Sun, orbiting at an average distance of about 228 million kilometers. This distance places it nearly 1.5 times farther from the Sun than Earth. Mars is significantly smaller than Earth, with a diameter of approximately 6,779 kilometers, about half the size of our planet. Despite its smaller size, its surface area is comparable to all of Earth's land masses combined. This makes Mars large enough to explore as a potential new frontier for humankind, yet small enough to remind us that it is not quite Earth. Its size influences its gravity, atmosphere, and ability to hold on to heat, all of which play critical roles in shaping the Martian environment. Mars has about 38% of Earth's gravity. For a human weighing 70 kilograms on Earth, the same person would weigh only about 26 kilograms on Mars. This reduced gravity would profoundly affect human physiology, bone density, and muscle strength. While lighter gravity might make carrying heavy equipment easier for astronauts, it also poses long-term health challenges for colonization. Additionally, reduced gravity influences the way dust and particles move in the atmosphere, contributing to Mars's infamous dust storms. One of the most defining features of Mars is its thin atmosphere, which is about 100 times less dense than Earth's. Composed primarily of carbon dioxide, 95%, with small amounts of nitrogen and argon, the Martian atmosphere is incapable of supporting human life as we know it. It lacks significant oxygen and provides little protection from solar radiation. Because the air is so thin, heat escapes rapidly, making Mars an extremely cold planet. Temperatures on Mars vary dramatically, ranging from highs of 20 degrees Celsius near the equator during the summer to lows of minus 125 degrees Celsius at the poles during winter nights. These extremes are due to the thin atmosphere's inability to retain heat and the planet's greater distance from the sun. Seasonal changes occur as Mars tilts on its axis at about 25 degrees, similar to Earth, creating variations in weather and temperature. These changes drive the advance and retreat of polar ice caps and sometimes trigger massive dust storms that can engulf the entire planet. The Martian surface is a canvas of both familiar and alien landscapes. Covered in iron-rich dust and rocks, the planet's reddish color is its most iconic trait. But beneath the rust lies a world of geological marvels. Mars is home to Olympus Mons, the largest volcano in the solar system. Standing nearly 22 kilometers tall, about 3 times the height of Mount Everest, Olympus Mons is so wide it could cover the entire state of Arizona. Its massive size is due to Mars's lack of tectonic plate movement, which allowed lava to build up over millions of years. Equally impressive is Valles Marineris, a canyon system stretching more than 4,000 kilometers long, up to 200 kilometers wide, and 7 kilometers deep. To put this into perspective, it is 10 times longer and 6 times deeper than the Grand Canyon on Earth. Scientists believe Valles Marineris was formed through a combination of tectonic forces, volcanic activity, and erosion, making it one of the most breathtaking features in the solar system. Mars also has polar ice caps composed of water ice and frozen carbon dioxide, commonly known as dry ice. These caps grow and shrink with the seasons, influenced by the planet's axial tilt and orbit. During winter, carbon dioxide from the atmosphere freezes onto the poles, creating thick layers of dry ice. In summer, this dry ice sublimates back into gas, releasing carbon dioxide into the atmosphere and slightly increasing its density. Beneath these seasonal layers lies permanent water ice, a resource of immense importance for future human explorers. The presence of water ice suggests that Mars not only has the raw materials for sustaining life, but also a potential supply for producing drinking water, oxygen, and even rocket fuel through electrolysis. One of the most dramatic aspects of Mars's environment is its global dust storms. Unlike Earth, where storms are largely driven by water vapor and oceanic systems, Mars's storms are fueled by solar heating of its dusty surface. These storms can grow so massive that they cover the entire planet, blocking sunlight for weeks or even months. The dust particles are incredibly fine, clinging to everything and posing risks to equipment, solar panels, and human habitats. For rovers powered by solar energy, such storms can mean the difference between survival and shutdown, as seen in the fate of NASA's Opportunity rover. Mars's landscape reveals a history of volcanism, tectonic activity, erosion, and impacts. Craters, its surface, some preserved for billions of years due to the lack of weathering processes that erase such marks on Earth. River valleys, deltas, and mineral deposits suggest that liquid water once flowed across the surface, carving channels and creating lake beds. These features point to a warmer, wetter past, raising questions about whether life may have once thrived there. While Earth and Mars share similarities, day length, axial tilt, seasons, and polar caps, they also differ drastically. Earth's robust atmosphere shields life from harmful radiation, maintains temperatures, and supports liquid water. Mars, on the other hand, is a frozen desert with little atmospheric pressure and no protective magnetic field. Yet it is precisely these differences that make Mars so intriguing. Studying Mars helps scientists understand how planets evolve and why Earth has remained habitable while Mars did not. In short, the physical characteristics of Mars make it a place of extremes and wonders. It is a planet where the tallest volcano meets the deepest canyon, where icy poles coexist with dusty deserts, and where storms can engulf the world in shadows. These features not only define Mars's identity, but also set the stage for the questions of life, exploration, and colonization that humanity continues to pursue. Water is the essence of life as we know it. On Earth, wherever there is liquid water, there is life. From the deepest oceans to the hottest springs, from the driest deserts to the frozen poles. When it comes to Mars, the search for water has been central to exploration because it directly connects to the search for life. Mars today is cold, dry, and barren, but overwhelming evidence suggests that billions of years ago, it was a very different world, a planet that may once have had lakes, rivers, and even oceans. Geological studies of Mars have revealed valleys, channels, and river deltas carved into the surface. These features strongly resemble those formed by flowing water on Earth. Orbital imagery from spacecraft like NASA's Mars Reconnaissance Orbiter, (MRO), and Europe's Mars Express has shown networks of dried riverbeds stretching across the planet. Craters that once held lakes have been identified, complete with layered sediments that indicate water once pooled there for long periods of time. The Gale crater, where NASA's Curiosity rover has been exploring since 2012, was once a vast lake. The rover discovered clay minerals there, which only form in the presence of water. Billions of years ago, scientists believe Mars had a thicker atmosphere capable of retaining warmth. During this time, liquid water could have flowed on the surface, forming rivers, lakes, and possibly an ocean in the northern hemisphere. Estimates suggest that this ocean might have covered nearly a third of the planet. This ancient blue Mars might have been much more hospitable to life than the cold desert we see today. So what happened? Why did Mars lose its water? The key lies in its atmosphere and magnetic field. Unlike Earth, Mars lacks a strong global magnetic field to shield it from the solar wind. Over time, solar radiation stripped away much of the atmosphere, causing surface pressure to drop and temperatures to plummet. As a result, liquid water could no longer remain stable on the surface. It either evaporated into space or froze beneath the soil. Today, water on Mars exists mainly in the form of ice at the poles, frozen beneath the surface, or bound within minerals. Occasional evidence of briny liquid water has been suggested, such as recurring slope lineae, dark streaks that appear and disappear seasonally on Martian slopes. Some scientists believe these may be caused by salty water seeping down the slopes, but this remains debated. Even if present, these brines would be extremely salty and harsh for most known forms of life. Still, they raise the possibility that Mars may not be entirely dry. Beyond simply proving that water existed, scientists are searching for signs that Mars could have been habitable. The discovery of clays, sulfates, and other minerals formed in water-rich environments points toward conditions that may once have supported life. In some areas, like Jezero Crater, where NASA's Perseverance rover is currently exploring, deltas and ancient lake beds provide prime targets for searching for biosignatures or chemical traces of past life. Perseverance is drilling into rocks, storing samples, and preparing them for a future mission that could bring Martian material back to Earth. These samples might hold microscopic evidence of past microbial life. The possibility of microbial life on Mars is one of the greatest scientific questions of our time. If life arose on Earth relatively quickly after conditions became favorable, could the same have happened on Mars billions of years ago? Microbes are resilient, capable of surviving extreme heat, cold, radiation, and dryness. On Earth, they thrive in environments once thought to be uninhabitable, such as hydrothermal vents and salt flats. If microbes once existed on Mars, they might have lived underground, protected from radiation, feeding on chemical energy from rocks and minerals. So far, no direct evidence of life has been found. Past missions, like NASA's Viking landers in the 1970s, conducted experiments to detect microbial activity in Martian soil. The results were inconclusive, sparking decades of debate. More recently, methane detections on Mars have stirred excitement. Methane can be produced biologically by microbes or geologically by chemical reactions. The fact that methane levels appear to fluctuate seasonally suggests an active source, but scientists are still trying to determine whether it is biological or not. Even though surface conditions on Mars are harsh, extremely cold, dry, and bombarded by radiation, the subsurface could tell a different story. In 2018, scientists using radar data from the Mars Express orbiter reported evidence of a liquid water lake buried beneath the ice at the South Pole. This discovery is controversial, but if confirmed, it raises the possibility that liquid water could exist underground in isolated pockets. In such environments, microbial life might still persist, shielded from the harsh conditions above. The presence of water, past or present, is critical not only for science, but also for future human missions. Water is heavy and costly to transport from Earth. If explorers can extract water from ice deposits or hydrated minerals on Mars, it would provide a vital resource for drinking, agriculture, and oxygen production. Moreover, water can be split into hydrogen and oxygen, creating rocket fuel for return journeys. In this sense, Mars's watery past and icy present could play a direct role in humanity's future. The search for water and life on Mars is more than just a scientific pursuit. It strikes at the heart of one of humanity's deepest questions. Are we alone in the universe? If life once existed on Mars, even in microbial form, it would prove that life is not unique to Earth. It would suggest that wherever conditions are right, life can emerge. This would have profound implications for the search for life on other worlds, such as the icy moons Europa and Enceladus, or planets orbiting distant stars. If, on the other hand, Mars never hosted life despite having favorable conditions, it would raise equally important questions. Perhaps life is rarer than we imagine, requiring an extraordinary chain of events to begin. Either way, Mars is the closest laboratory we have for exploring these questions. Its dry riverbeds and ancient lakes hold the keys to understanding life's possibilities beyond Earth. Mars has long captured the human imagination, but our understanding of the planet has grown most dramatically in the last century through science and exploration. What began as telescopic observations from Earth has transformed into a fleet of orbiters, landers, and rovers exploring the red planet up close. The story of Mars exploration is one of persistence, innovation, and international collaboration, marked by both stunning successes and humbling failures. For centuries, humans gazed at Mars through the naked eye. Ancient civilizations such as the Babylonians, Egyptians, Greeks, and Romans associated Mars with gods of war due to its blood-red hue. With the invention of the telescope in the 17th century, astronomers began to notice surface features, dark patches, polar caps, and seasonal changes. In the late 19th century, Italian astronomer Giovanni Schiaparelli reported seeing canali, channels on Mars. These were mistranslated into English as canals, fueling speculation that intelligent beings had constructed massive waterways. Popular culture soon embraced the idea of Martians, giving rise to science fiction classics such as H.G. Wells's The War of the Worlds. While later observations showed that the canals were optical illusions, the idea that Mars might harbor life or advanced civilizations lingered in the public imagination for decades. Even today, the dream of discovering life on Mars owes much to this early era of wonder. The space age began in the mid-20th century, and Mars quickly became a target. The Soviet Union and the United States attempted multiple missions in the 1960s, but most ended in failure. Mars was a difficult planet to reach. The thin atmosphere, precise orbital timing, and long travel distances made success elusive. The breakthrough came in 1965 when NASA's Mariner 4 flew by Mars, capturing the first close-up images of its surface. These photographs shocked the world, revealing a cratered, moon-like landscape that seemed lifeless and desolate. Gone were the dreams of lush Martian forests or alien cities. Yet, even in its barrenness, Mars inspired awe. Later missions, Mariner 9 in 1971 and NASA's Viking landers in 1976, expanded our understanding. Mariner 9 became the first spacecraft to orbit another planet, mapping volcanoes, canyons, and dust storms. The Viking landers conducted experiments to search for microbial life. While they did not find conclusive evidence, they provided invaluable data about soil chemistry and atmospheric composition. After a period of limited activity in the 1980s and early 1990s, a new wave of exploration began. NASA's Mars Pathfinder mission in 1997 successfully deployed the Sojourner rover, the first wheeled robot to move across the Martian surface. This achievement sparked excitement for more ambitious missions. The 2000s marked a golden era of Mars exploration. NASA's Spirit and Opportunity rovers, landing in 2004, transformed our understanding of the planet. Designed for 90-day missions, they lasted years. Opportunity operated for nearly 15 years before a dust storm ended its mission in 2018. These rovers discovered evidence of past liquid water, including hematite blueberries, sedimentary rocks, and minerals formed in wet environments. Meanwhile, orbiters like Mars Odyssey, Mars Express from the European Space Agency, and Mars Reconnaissance Orbiter, MRO, mapped the planet in unprecedented detail, locating ice deposits, monitoring dust storms, and serving as communication relays for surface missions. In 2012, NASA's Curiosity rover landed in Gale Crater, embarking on a mission to determine whether Mars ever had the conditions to support life. It found that ancient Mars had the necessary ingredients: water, energy sources, and essential elements. Curiosity's discoveries shifted the focus from "was Mars ever like Earth?" to "could life have once existed here?" The current era of Mars exploration is even more ambitious. In 2021, NASA's Perseverance rover landed in Jezero Crater, an ancient lakebed believed to be one of the best places to search for past microbial life. Equipped with advanced instruments, Perseverance is collecting and storing rock samples for a future mission that aims to bring them back to Earth, a historic first. Accompanying Perseverance was Ingenuity, a small helicopter that made history as the first aircraft to fly on another planet. Initially designed for just a few test flights, Ingenuity exceeded expectations, performing dozens of flights and scouting terrain for the rover. This groundbreaking achievement opened new possibilities for aerial exploration of other worlds. Mars exploration is no longer limited to NASA. In 2021, China's Tianwen-1 mission successfully placed an orbiter around Mars and deployed the Zhurong rover, marking China as the second nation to land and operate a rover on the Red Planet. The United Arab Emirates also launched the Hope orbiter, which studies Mars's atmosphere and climate. These missions highlight the growing international interest in Mars. While robotic missions have revolutionized our knowledge of Mars, the ultimate goal remains human exploration. Space agencies and private companies are planning the first crewed missions within the coming decades. NASA's Artemis program, which aims to return humans to the Moon, is seen as a stepping stone for Mars. The agency envisions sending astronauts to Mars in the 2030s. Meanwhile, SpaceX, led by Elon Musk, has announced bold plans to send humans to Mars using the Starship spacecraft. Musk's vision goes beyond exploration. He imagines building a self-sustaining city on Mars, making humanity a multiplanetary species. While these plans face immense technical, financial, and ethical challenges, they reflect the seriousness of human ambition. Before humans can set foot on Mars, key technologies must be perfected. These include life support systems, radiation shielding, reliable propulsion, landing systems for massive spacecraft, and the ability to generate food, water, and fuel on Mars itself. The journey to Mars would take 6 to 9 months each way, requiring resilience, endurance, and new strategies for human survival in deep space. Exploring Mars is about more than science. It is about human destiny. Robotic missions are paving the way, but only humans can fully explore, adapt, and eventually thrive on another world. Mars represents the next great frontier, much like the oceans once did on Earth. Every mission brings us closer to answering profound questions. Did life ever exist beyond Earth? Can we live sustainably on another planet? What does it mean to expand human civilization across worlds? Mars exploration unites nations, inspires generations, and pushes the boundaries of technology. It forces us to think long-term about survival, cooperation, and stewardship of both Earth and other planets. In this sense, the journey to Mars is as much about the human spirit as it is about science. While robotic missions have shown us that Mars is a planet of wonders, colonizing it is a completely different challenge. Surviving on Earth depends on a delicate balance of atmosphere, temperature, magnetic field, and abundant resources that support life. Mars, by contrast, is harsh, unforgiving, and fundamentally hostile to human survival. Yet, it is precisely this challenge that makes it the ultimate test of human ingenuity. Colonizing Mars will not be easy, but it may be possible through science, innovation, and determination. One of the greatest dangers for humans on Mars is radiation. Unlike Earth, Mars lacks a strong magnetic field to protect against cosmic rays and solar radiation. On Earth, our atmosphere and magnetosphere deflect harmful radiation, allowing life to thrive. Mars's thin atmosphere, however, offers almost no shielding. Astronauts on Mars would be exposed to much higher doses of radiation than on Earth, increasing the risk of cancer, organ damage, and genetic mutations. Prolonged exposure could be deadly without proper protection. To counter this, colonists would need to build habitats underground or shield them with thick layers of Martian soil, regolith. Another idea is to use water or ice as a protective barrier since water is an effective radiation absorber. Developing advanced radiation shielding is one of the top priorities for future colonization. Mars's atmosphere is composed of 95% carbon dioxide, 3% nitrogen, and only trace amounts of oxygen. Humans cannot breathe this air. Additionally, the pressure at the Martian surface is less than 1% of Earth's, roughly equivalent to standing 30 kilometers above Earth's surface. Without a pressurized suit or habitat, humans would suffocate within minutes. To survive, colonists will need to build sealed, pressurized habitats and wear specialized suits when venturing outside. Scientists are also exploring ways to generate oxygen from the Martian environment. NASA's Perseverance rover is already testing the MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, device, which converts carbon dioxide into breathable oxygen. While MOXIE is small, it proves that future larger systems could provide life-sustaining oxygen for colonies. Mars is a cold desert. Average temperatures hover around -63 degrees Celsius, with nighttime lows dropping to -100 degrees Celsius or below. Even at the warmest times near the equator, daytime temperatures rarely rise above 20 degrees Celsius. This extreme cold poses challenges for human survival, technology, and agriculture. Equipment must be designed to withstand freezing conditions, and colonists will rely heavily on heating systems. The thin atmosphere also allows rapid heat loss, creating large temperature fluctuations between day and night. Future habitats must be insulated and equipped with reliable power sources, possibly using nuclear energy, solar farms, or even geothermal energy if accessible. Mars is covered in fine dust, composed of iron oxide and other minerals. This dust is not only pervasive but also potentially harmful. It can damage machinery, clog filters, and interfere with solar panels. Inhaled dust could be dangerous to human lungs, especially if it contains toxic compounds like perchlorates. Adding to this challenge are Mars's infamous dust storms, which can grow so large they cover the entire planet for months. These storms block sunlight, reducing solar power and plunging habitats into darkness. Future colonists will need to develop robust energy systems and dust-proof technology to survive such conditions. Unlike Earth, Mars does not have vast, easily accessible resources for human use. Water exists mainly as ice in polar regions and underground deposits. Extracting this water will be essential, not only for drinking but also for agriculture and fuel production. Food is another major challenge. Colonists cannot rely on resupply missions from Earth, as the distance makes deliveries expensive and infrequent. Instead, they will need to grow food locally. Experiments on Earth and aboard the International Space Station, ISS, have shown that plants can grow in controlled environments using artificial light and hydroponics. On Mars, greenhouses will need to be tightly controlled, with recycled water, artificial lighting, and possibly Martian soil modified to remove toxic chemicals. Energy production is equally vital. Solar panels are a natural option, but dust storms and reduced sunlight intensity compared to Earth make them less reliable. Nuclear reactors may become the backbone of Martian colonies, providing consistent power regardless of surface conditions. Living on Mars is not only a physical challenge, but also a psychological one. Colonists will be isolated from Earth, separated by millions of kilometers and communication delays of up to 20 minutes each way. The sense of isolation and confinement, combined with dangerous conditions outside, could cause stress, depression, and conflict within crews. To address this, mission planners must focus on mental health, community building, and recreation. Habitats may include communal spaces, simulated natural environments, and digital connections with Earth to help colonists feel less isolated. Team selection and training will also be critical, ensuring that crews can work together harmoniously under pressure. Even before reaching Mars, the journey itself poses challenges. Depending on planetary alignment, it takes 6 to 9 months to travel from Earth to Mars. Astronauts would spend this time exposed to microgravity and radiation in deep space, which can weaken muscles, reduce bone density, and strain the body. Technologies such as artificial gravity or advanced shielding will be necessary for long-term missions. Resupply from Earth is difficult. Launch windows for Mars occur roughly every 26 months, when Earth and Mars are optimally aligned. This means colonies must be self-sufficient, capable of surviving without frequent shipments from Earth. Building a sustainable supply chain of local resources is crucial for long-term colonization. Some visionaries have proposed terraforming Mars, altering the planet's climate to make it more Earth-like. Ideas include releasing greenhouse gases to warm the atmosphere, redirecting comets to deliver water, or deploying giant mirrors in orbit to reflect sunlight onto the surface. While fascinating, these concepts remain theoretical. Current technology is far from capable of transforming an entire planet, and such efforts would take centuries, if not millennia. For now, colonization efforts focus on adapting humans to Mars rather than adapting Mars to humans. Colonizing Mars also raises ethical questions. Should humans alter or exploit another planet before fully caring for Earth? What if microbial life exists on Mars? Do we have the right to disturb or contaminate it? Scientists emphasize the importance of planetary protection, ensuring that human activity does not irreversibly harm Martian ecosystems or obscure the search for native life. Balancing exploration with responsibility is one of the greatest philosophical challenges of colonization. Despite these immense obstacles, solutions are being developed. International cooperation, private investment, and advances in science are bringing us closer to a reality where humans may set foot on Mars. Colonization will likely begin with small outposts, gradually expanding into larger settlements as technology and resources improve. Each step will require overcoming problems of radiation, atmosphere, food, water, and psychology. Mars will test humanity's creativity like no other challenge. But in facing these difficulties, we will gain technologies and knowledge that can also benefit Earth. From renewable energy systems to recycling technologies, innovations driven by Mars exploration could help address challenges at home. Long before robotic explorers sent back images of Mars's rocky plains, human beings looked up at the night sky and gave meaning to its fiery glow. Mars, with its blood-red color, stood out among the wandering stars. It inspired myths, religions, and works of art across civilizations, shaping how humanity imagined its place in the cosmos. Beyond science, Mars has always been a planet of the mind, a canvas on which people projected their fears, hopes, and dreams. In ancient times, Mars's reddish appearance evoked associations with war, blood, and power. To the Babylonians, it was Nergal, a god of destruction and death. The Greeks named it Ares, the god of war, symbolizing chaos and conflict. The Romans carried this tradition forward, calling it Mars, their own god of war, after whom the planet is still named today. Mars was not only associated with war but also with masculinity, strength, and fertility in some cultures. The symbol of Mars, male sign, is still used in modern times to represent the male gender, derived from the shield and spear of the Roman god. In Hindu tradition, Mars is known as Mangala, a deity linked with strength, aggression, and action. Ancient Chinese astronomers referred to it as the fire star, a harbinger of misfortune. Across the world, Mars carried an aura of power and danger, reflecting humanity's awe of the heavens. As astronomy advanced, Mars became one of the most studied planets. Its visible polar caps, seasonal changes, and moving dark patches sparked speculation about life. In the 17th century, Dutch astronomer Christian Huygens drew some of the first detailed maps of Mars, noting surface markings. Later, in the 19th century, Giovanni Schiaparelli observed canali on Mars, interpreted by some as artificial canals. This mistranslation fueled wild theories that Mars was home to an advanced civilization struggling to survive on a dying planet. American astronomer Percival Lowell popularized the canal idea, imagining a network of water channels built by intelligent Martians. His books captured public imagination and made Mars the most likely candidate for alien life in the popular mind. Though later disproven, these ideas left a lasting impact on science fiction and culture. Mars became the stage for countless stories, blending scientific curiosity with human imagination. In 1898, H.G. Wells published The War of the Worlds, in which Martians invade Earth with advanced technology. The novel reflected contemporary anxieties about imperialism and survival, but it also cemented the idea of Mars as a planet of alien life. Orson Welles' 1938 radio adaptation of the story famously caused panic among listeners who believed the invasion was real. Edgar Rice Burroughs created the Barsoom series, starting with The Princess of Mars in 1912, envisioning Mars as a desert world inhabited by strange creatures and warrior societies. These stories combined adventure with romanticism, inspiring future generations of science fiction. Ray Bradbury's The Martian Chronicles, 1950, took a more poetic and philosophical approach, using Mars as a mirror for humanity's hopes, fears, and destructive tendencies. Through these works, Mars became not just a planet but a stage for exploring human identity. In more recent decades, authors like Kim Stanley Robinson with his Mars trilogy, Red Mars, Green Mars, Blue Mars, imagine the scientific, political, and social aspects of colonizing Mars in painstaking detail. His works remain some of the most influential explorations of how humanity might truly settle the Red Planet. The 20th and 21st centuries saw Mars dominate cinema and television. Films such as Robinson Crusoe on Mars, 1964, Total Recall, 1990, and Red Planet, 2000, depicted survival and exploration on Mars. The idea of hostile Martians attacking Earth was popular in movies like Mars Attacks, 1996, while more serious depictions of human missions appeared in Mission to Mars, 2000. One of the most realistic portrayals came with Ridley Scott's The Martian, 2015, based on Andy Weir's novel. The film depicted an astronaut stranded on Mars, using science and ingenuity to survive. It highlighted the practical challenges of colonization while celebrating human resilience. More recently, shows like Mars, National Geographic, have blended documentary and fiction to explore the future of Martian colonization. Mars has also been a recurring theme in video games, from the alien landscapes of Doom to the survival mechanics of Surviving Mars. These portrayals reflect not only entertainment, but also humanity's deep curiosity about what life might be like on the Red Planet. Today, Mars stands as a symbol of the future. For visionaries like Elon Musk, Mars is the ultimate destination, representing humanity's chance to become a multiplanetary species. In popular culture, Mars is often portrayed as both a challenge and a promise, a place where humans may find a new beginning, but only through struggle. Mars also carries symbolic weight in art and philosophy. It embodies the dual nature of human ambition, our destructive tendencies, as reflected in its mythological association with war, and our creative drive to explore, innovate, and build anew. The planet's red glow reminds us of both danger and opportunity, mirroring our own complex relationship with progress. The way humanity imagines Mars shapes the way we explore it. The myths of ancient gods gave Mars a sense of power. The canals of the 19th century inspired science fiction. Modern visions of colonization motivate real-world missions. Culture and science feed each other. Fiction inspires exploration, and exploration inspires new stories. This cultural fascination also plays a practical role. Public support for space missions often depends on imagination. When people dream of stepping on Mars, of seeing human footprints in its dust, they are more likely to support the scientific and political efforts required to make it happen. Mars, therefore, is not just a scientific target, it is a cultural journey. Mars has always been more than a planet. It is a mirror reflecting humanity's past, present, and future. From gods of war to alien invaders, from deserts of death to potential new homes, Mars carries every shade of our imagination. The planet is both a warning and an invitation, warning us of fragility, but inviting us to dream bigger. In the end, Mars in culture and mythology reminds us that exploration is not only about science. It is about meaning, identity, and the stories we tell about ourselves. Mars is where science meets art, where myth meets reality, and where humanity's greatest adventure continues to unfold. Throughout history, Mars has been many things to humankind: a god of war, a celestial mystery, a stage for imagination, and now a real frontier. From its red glow in the sky to the dusty plains captured by rovers, Mars has guided us on a journey that is both scientific and deeply human. To conclude this exploration, it is important to ask, why does Mars matter? Why do we invest so much time, imagination, and resources into reaching this distant world? The answer lies in a blend of curiosity, survival, and the search for meaning. At its core, Mars is a natural laboratory. It preserves clues about the formation of planets, the presence of water, and the potential for life beyond Earth. By studying Mars, scientists learn not only about the red planet but also about Earth's own history. Did Mars once host oceans and a thick atmosphere? Could life have evolved there billions of years ago? These questions drive research and spark the imagination. Discovering even the faintest evidence of ancient microbial life would revolutionize our understanding of biology and confirm that life is not unique to Earth. Mars also offers lessons about climate. Its transition from a wetter, warmer planet to the frozen desert we see today provides warnings about planetary change. Understanding this transformation could help humanity protect Earth from environmental collapse. Thus, Mars is not just an alien world. It is a mirror showing us possibilities for our own planet's future. Reaching and settling Mars is one of the greatest engineering challenges humanity has ever faced. The distance is immense, the environment hostile, and the risks monumental. Yet, the very difficulty of the task is what makes it meaningful. Just as climbing Mount Everest was not about comfort but about pushing human limits, reaching Mars represents our collective ability to go beyond the familiar. Every rover, orbiter, and mission is a stepping stone toward this goal. The technologies developed, life support systems, renewable energy solutions, radiation shielding, will not only make Mars exploration possible, but also benefit life on Earth. In this way, Mars acts as both a destination and a driver of innovation, forcing us to become smarter, more resourceful, and more united. Mars also represents a vision of survival. Earth is our cradle, but it is vulnerable to natural disasters, climate change, and even cosmic events like asteroid impacts. To secure the long-term survival of humanity, many thinkers argue that we must become a multi-planetary species. Mars, with its relatively Earth-like day length, seasons, and resources, is the most logical first step. Colonizing Mars will not be easy, but the dream itself drives progress. It forces us to think about sustainable living, recycling resources, and cooperation on a global scale. If humanity can thrive on Mars, it proves that we can adapt to almost any environment. In that sense, Mars is not just a refuge, it is a proving ground for the resilience of human civilization. Beyond science and survival, Mars is a symbol. It embodies curiosity, imagination, and the desire to explore the unknown. Just as the moon landing symbolized human achievement in the 20th century, stepping onto Mars will define the 21st and 22nd centuries. It will show that humanity is not bound to one world, that we can extend our reach into the cosmos. Mars also unites people. Unlike earthly conflicts, the challenge of exploring Mars belongs to everyone. It is not the domain of one nation, but of all humanity. The red planet stands as a reminder that our greatest challenges and dreams require collective effort. To look at Mars is to see not only a planet, but also a shared destiny. Already, the journey to Mars is unfolding. NASA's Artemis program aims to return humans to the moon as a stepping stone. SpaceX dreams of launching Starship missions that could one day transport settlers to Mars. International partnerships envision sustainable bases and scientific outposts. The road will be long, filled with failures and triumphs, but every step will bring us closer to answering questions that have haunted humanity for centuries. Are we alone? Can we live beyond Earth? What kind of species will we choose to be? Mars is more than rock and dust. It is a dream, a challenge, a promise. It tells us about our past and points toward our future. Mars is not the end of exploration. It is the beginning of a new era. The red planet calls us, and humanity will answer.